So welcome to the second part of solving logarithmic equations. Now, we have an example here. So we have the log of x to base 3 plus the log of x squared to base 9 equals to 4. Now notice one thing, the bases here are different. So we have different bases. So you can use different methods of solving this. Now I'm going to teach you a very simple and a very direct way in handling such an equation. Now let's take the solution. Now, from the introduction of logarithms, there's something we noted. That if you have the log, let's say 8 equals to 3, we said that this base raised to this power gives you this number. So the base here, this one is our power, always give you this number. And you can confirm that 8 is the same as 2 cubed. Now there's a concept I want to teach you, that now, if by any chance you check your bases, when you have this basis and you check one base is related to the other, you can change all the bases to be of 1, to be the same, by using the same relationship. Now let's check another relationship here. Log, let's say 4 equals to 2. So what will be our power that we'll have here for us to get 2? So what will we have as our x for us to get 2? So expanding this, we know this one gives us what? 2 is the same as 4 raised to power 4 raised to power x. So for us to find 2, and therefore 2 you can write 4 as a power. So we can say it is 2 raised to 2. Then we have our x here. So remember this is 2 to power 2. This is 2 squared, which gives us 4. Yeah, it gives us that. So remember this one, our power is 1. So therefore this power and this power should be the same. So we have 1 equals to 2x. So for us to find the value of x, we find 2 divided by 2. So x equals to what? X is equals to a half. So therefore, if we have a power here and you want to change, you want to find the number that gives us this. So you can see this number is bigger than this. But in one or the other, they are related. The two numbers are related. And you can see the square root. When you have the square root which is written, when you have a fractional number, so if you have 4 raised to a half, this means a root. This one is the power, this one is the root. This means the square root of 4, in short. Means the square root of what? The square root of 4. The square root of 4, not 2. The square root of 4 which gives us 2. So you can see this relationship from what we learned before, and that is what we're going to use here to change this base to become a base of 3. So this also, for us to find our number here, we can change this number here and write it as the same as this, the logarithm. So let's check one thing here. So we know our answer is a half. So we can say this, the log of 2 to base 4, the log of 2 to base 4 can also be rewritten as the log of 2. You can write this one as a base of 2, which is the same as 2 squared. So the 4 is the same as 2 squared. Now you can take this power here and bring it here, but you shall bring it as a fraction. So this is the same as saying a half. So this 2 becomes 1 over 2, then log. Then you will remain with 2, and you remain with 2. And what do we know about logarithms? So the log of 2 to base 2 is always 1. So this one is 1. So therefore our answer is still a half. That is the knowledge we're going to use here to exchange this. So therefore, let's now solve our equation here. So we have the log of 3, the log of x to base 3 plus the 3 log 9x squared equals to what? Equals to 4. So rewriting this to the base of 3 plus 3 log. So now let's write this to be at the base of 3. This one is the same as 3 what? 3 squared. So you can write it 3 squared, then x squared equals to 4. Now again log 3x plus. We are saying you can get this power out of the base here and bring it here, but we'll bring it as a fraction, as an inverse. So we can say reciprocal also. So So it is 3, then this one is 2. So you write it as 1 over what? 1 over 2, then the log of what? Of 3. So you remain with the log of 3 because you remove the 2, then x squared equals to 4. Now you can see we have already changed now everything to be to the base of 3. You can see that. Now another law of logarithm, if you have the log, remember, LB, if you have the log of to a certain base of a to power n, this one is the same as saying what? Drop the n, so you have n, the log of a. So therefore, in our case here, we can drop these 2. So you can drop these 2 here. So we have not cancelled or opened the bracket because something will cancel out. So using this, we are going to apply this. So let's have it here. So we have log 3x plus 3. Then we have a half here. Then drop these 2. So we drop the 2 that was on the x. Then the log of 3x equals to what? Equals to 4. Now from there, we can now simplify. So we have log 3, log x to the base of 3 plus. So these are half and these 2 can cancel out. And that can cancel. So we remain with 3. The log of 3x equals to what? Equals to 4. Now you can note this term and this term are the same. 3 log of x to base 3. Log of x to base 3. So this one is 1. This one are 3 of them. So therefore, so this one is 1 log x to base 3, and this one are 3 log x to base 3. So what is the total? There are 4 of them. So log 3x equals to what? Equals to 4. Divide 4 both sides. Divide by 4. Divide by 4. So find log of x to base 3 equals to what? Equals to 1. And what do we know about logarithms? That this base raised to this power gives you this number. So therefore our x will be 3 power 1. So our x therefore will be what? Our x will be 3. That is how simple, that is the simplest way you can handle that question. Let's check example number 2. Example number 2. We have the log of 2 to base x minus the log of x to base 4 plus 7 over 6 equals to 0. Now, in this example, we're going to use the change of base. We're going to use the change of base because one, we can see we don't have a common base. We don't have a common base here in either of these. So we're going to use the rule of change of base. We said you have the log of m, the base of p. This one can be changed to become what? The log. You introduce a common base n, then this number here, then over the log of n, then our p. So using the laws of the change of base, you can apply this formula. So that is what you're going to do here. So you're going to change them to be of a common base, either 4. So in this case, we're going to change it to be the same as 4 because it is a number. So you can change it to the base of 4. Which is a number. We said you can change to the base, your convenient base that you can see works best. So for such an example, let's change everything here to be to the base of 4. So we start with the first one. So we shall have log to base 4, then of what? 2. Okay? Over log to base 4 of what? Of x. We have that. Then minus. This one is already to base 4, so we don't change it. So x plus 7 over 6 equals to what? Equals to 0. So we have that. Now, we can find the solution for this. We can find the solution for this because what do you know? As we said, you can write this, you can have log of 4 to base 2 and be written as log. Write this one as 2 squared. 2 squared, then you have 2 there. So the 4 is written as 2 squared. And we say you can write, you can take this a half, I'll take this 2 and write it as a half. So you can write it as a half here. Then you have the log of what? The log of 2, 2. So the log of 2 to base 4 will just simplify to become what? Because this one, we know this one, using this log of a to base a is always 1. So therefore, our number here is 2 and our base is 2 and our number is 2. So therefore, this one simplifies to become 1. So therefore, log of 2 to base 4 simplifies to become a half. So therefore, in writing this, we shall have the log. Now, the upper side now simplifies to become a half. Then we have log of 4x minus log of 4x plus 7 over 6 equals to what? Equals to 0. Now, in our case here, we can let this value to become a letter. So we can let here log 4x to become y. Log of x to base 4. So therefore, we shall have a half over y minus y plus 7 over 6 equals to what? Equals to 0. Multiply everything by y. First of all, we can start by multiplying by y. So multiplying by y, multiply by y. So when you multiply this one by y, you remain with a half. Then minus y times y squared, plus 7 over 6, then we shall have 7 over 6 what? Y equals to 6. Now we don't want to work with fractions. You can remove these fractions that we have here, the 6 and the 2. So you can find the LCM of 2 and 6, and basically it's just 6. So the LCM will be 6. Now multiply by 6, multiply by 6. By 6. Remember, you're multiplying everything by the same number. So if you multiply by y, you're multiplying the left hand side and the right hand side. But when you multiply the right hand side, you just find it will still be 0. So the same way here, multiply this one by 6 now, this one will become 3 minus by 6 y squared by 6 plus 7y, then this one remains 0. Now let's rearrange it to become a quadratic equation. Now we have negative 6y squared plus 7y plus 3 equals to 0. We can multiply all through by negative so that we make this number to be a positive number. So multiplying by a negative all through the right hand side and the left hand side, we remain with what? 6y squared minus 7y minus 3 equals to what? Equals to 0. Now you can see we have a quadratic equation. Therefore, let's now solve the quadratic what? The quadratic equation. Now, we have 6y squared minus 7y minus 3. So, what do? We find two numbers whose product, we say the product should be AC, where your A is this number, I'll just say AC, where your A is always the number with the square and the constant here. This one is your A, this one is your C, this one is your B. So we always have A, B, C. Then remember, a number carries a sign before it. So our number A is 6, our number B is negative 7, our number C is negative 3. So therefore, our product therefore will be 6 times negative 3, which will be negative what? Negative of 18. Then 2, our B, the sum. We find two numbers which will give you the sum to be B. So our B therefore is negative 7. So you find two numbers whose sum is negative 7, whose product is negative 18. And we say you always use, the best way to find the two numbers, always use the product. So we find the product of 18, two numbers that can give you 18. So we have one, we can have 6 times 3, we can have 9 times 2, we can have 18 times 1. So you can have these two numbers. And now we find a combination of either of these two numbers which will give you a product of negative 18 and a sum of negative 7. and you can check them through and see which one gives you, and you will find out that these two numbers will give you the best combination, where one of them has to be negative either way, because you can see the product and the sum are all negatives. So which one will we put as a negative? Basically, we'll put negative 2 to be our negative number. So therefore, simplifying this, so our two numbers are 9 and negative 2. Reason being, there's the other way around, sorry, it's 2, negative 9. So that when you add negative 9 plus 2 gives you negative 7. When you multiply negative 9 times 2 gives you what? Gives you 18. So let's now simplify this. So we have 6y squared. Then we rewrite these two factors here. So we will have plus 2y minus 9y minus 3 equals to what? Equals to 0. So we have just inserted the 2 and the 9, the negative 9 here. So therefore, taking two terms that are both this, and taking like terms. So we can see we have a 2 as a like term and we have a y. So you can take 2y outside. So you remain with what? 3. Then 0 is y squared, you remain with a y there. Then plus. So this one is 2, so 2y, therefore our number there is 1. Therefore again you have minus. You'll have minus. What is the common term there? It is 3. So you have 3. Then remember, this term should always be the same as this term. So the factor or the sign that you put here is very important. Remember, we have put our us to be negative. So that when you have 3y plus 1, negative 3y times, negative 3 times 3y gives you negative 9y. Negative 3 times 1 gives you negative 3. So by the end of the day, it gives you the same thing. Then take like terms, both sides. So we take this and this, the outside numbers, minus 3. Then you have 3y plus 1 equals to 0. And we say, if you have two factors which are multiplied together to give you a 0, either of them was a 0. So it is either this one equals to 0 or this one equals to what? Equals to 0. So therefore, let's solve each at a go. So we have 2y minus 3 is either 0. So taking 3, negative 3 on the other side, you have this one. And then you have positive 3. Therefore, divide by 3 divided by 3. Sorry, by 2, not 3. So divide by 2, so that will remain 2. So our y equals to 3 over what? 3 over 2. Or 3y plus 1 is also equals to what? Equals to 0. So therefore, 3y equals to negative 1. Take 1 on the other side. Therefore, y given by negative 1 over 3. So we have the two values of y. But is this the final solution? No, it is not the final solution, because what did we do in the beginning? We say let. Remember, there's something that we let. Remember, we had let our log of 4x equals to y. So we have only found the values of y. So therefore, we need to find the values of x. We are solving for x. So therefore, replacing the two values of y, we can find the two values of x. So it is either the log of 4 or x equals to 3 over 2, or the log of x base 4 equals to negative what? 1 over 3. Therefore, remember again, this one is the base, this one is the what? Is the power. Therefore, x is the same as 4, 3 over 2 as your power, or x is equals to 4 then to power negative 1 over what? Negative 1 over 3. Now, there is something very important I want to teach you today. Especially when you're working with a calculator, it is so important to note one thing. When you key in fractions in terms of powers, you must put the brackets. Reason being, now let's check it. And from the laws of indices, we know one thing. This one is the power, this one is the root. This one is the power, this one is the what? This one is the root. Now let's check two solutions. Let's check our the other solution without putting the brackets. If you take using the fx, it's a 2ms. If you take 4, you raise it to power 3 over 2 without putting the brackets, we get our answer to be what? To be 32. Now, let's check the other way around. 4, you raise it to power, put the brackets, so you open the brackets, then 3 over 2, then what do we get our solution? Our solution is 8, which is the correct solution. So our solution of x, so you always must put the brackets when you're working with a calculator. And we want to prove, let's prove that our 8 is indeed correct and the other one is wrong. We say this one is the power, this one is the root. Now this is the same as saying 4 power 3, then square root. So 4 to power 3 gives us what? 4 to power 3 gives us 64. So 64. Then, and what is the square root of 64? The square root of 64 is what? Is 8. That means if you did this solution without using the bracket, then you get the wrong answer here. So our correct answer is 8. Therefore, our value of x, now you can try this. What is x? What is 4 raised to the power of negative a third? Now remember to put the brackets. So what do you see? Can you do that? As we do it together. So 4, then the bracket plus, into bracket, negative a third gives you 0.6. We can say 63 because we round off the numbers that follow, gives you that. So our solutions for x is x equals to 0.63 or x equals to 8. Now let's check the last example that we have here. So the log of 5 to the base 10 minus 2 plus the log of 2x plus 10, the base of 10, equals to the log, the base is 10, x minus 4. So this one is simpler because we're just going to use the laws of logarithms simply because we have them to be on the same what? The same base. So here you're just required to know the laws and which one you can apply. Now, solution. So we have a constant term here. So you can take it to the right hand side and take this one the left hand side. So rearranging this, we have log 10 power 5 plus log, base 10 of 2x plus 10. Then take this one to this other side so that you can have the logs on one side, x minus 4. Then this one is minus 2, goes to the other side, becomes what? Positive of 2. Now the laws of logarithm says if you have two numbers added, then they were multiplied. If you have a number divided, then it was subtracted. So you can write all these and put them under one log, that is log to the base of 10. So therefore this is just the same as saying log to base 10. Now this and this are added, so you multiply them. So 5, 2x plus 10. Then this one is subtracted, so you divide by this. So the whole of this divided by x minus 4. Then this one gives you what? Should give you 2. Now, we know one thing, that this base raised to this power, okay, this base raised to this power gives you this number. So now let's rearrange this. So we have 5, 2x plus 10 over x minus 4 should give you 10 squared. Alright, so this base raised to this power gives you this number. So therefore, this number is the same as this raised to power that. So that one. So we can open up the brackets, now solve. So we have, this one is 10x plus 50 equals to x minus 4 equals to 100. Now, so we can see this one is just a linear algebraic equation. So let's solve for that. So therefore we have 10x plus 50 over x plus 4 equals to 100. So multiply this. On this side, this one is minus, we have minus. So multiply it on the other side because this one is over 1. So you cross multiply. So remain with 10x plus 50 equals to 100 multiply by x minus 4. So we have 10x plus 50 equals to 100x minus 400. Take like terms on one side. So you can choose to take 10 on this side, then 400 on this side. So we have 400 is negative, it comes to this side, it becomes positive. So we have 50 plus 400. Now 10 is positive, take it to the other side, it becomes negative. So we have 100x minus 10 of what? 10 of x. So this one becomes 450 equals to 90x. So therefore divide both sides by 90. So we have 90, we have 90. So that and that goes. This one goes here how many times? 5 times. And your value of x is equals to what? Is equals to 5. Easy, easy. So that is how we solve such a question. So remember, and that brings us to the end of logarithmic equations and the whole topic of logarithm and indices. So feel free to ask questions, feel free to comment. If the lessons have been helpful to you, kindly subscribe, like, and also share to your friends, to your colleagues, to your family members who are studying in colleges, in universities, also in high schools, and these shall be helpful to you. So kindly, you can also check the playlists. I've arranged everything in terms of a playlist. So logarithm and indices, when you go to my channel, is in one playlist. So you can have the lesson from the first lesson that we did up to the last lesson. So thank you very much, and see you in the next lesson.